Here is today's problem. We are given 3 to the x plus 3 to the x plus 3 to the x, and that entire sum is equal to 72. Our job is to find the value of x that makes this true. Let us start by looking closely at the left-hand side. There are 3 terms there, joined by plus signs. The first term is 3 raised to the power x, the second term is also 3 raised to the power x, and the third term is 3 raised to the power x again. So all 3 terms are exactly the same expression. That repetition is something we can work with directly, so we will call that repeated expression t. In other words, t is defined as 3 to the power x. Every time we see 3 to the x, we can write t instead. A single letter is easier to handle than a power, and nothing about the equation changes when we rename it. This keeps the equation short while we rearrange it, so the left side becomes t plus t plus t, and the right side simply stays as 72. So our equation is now t plus t plus t equals 72. That is a simple linear equation in the variable t. Adding one copy of t to another copy gives 2t. Adding a third copy of t gives 3t in total. So the left side collapses neatly into 3t. If we have 3 of anything, we write 3 times it. Our equation is now 3t equals 72. To isolate t, we divide both sides by 3. On the left, 3t divided by 3 leaves just t. On the right, we need 72 divided by 3. 3 goes into 7 twice, with 1 left over. That leaves 12, and 3 goes into 12 4 times. So 72 divided by 3 is exactly 24. We can check that quickly by multiplying back. 3 times 24 is 72, which matches. So we have found that t is equal to 24, so each copy of t carries a value of 24. Before moving on, we should think about what t can be. T was defined as 3 raised to the power x. A positive base raised to any real power stays positive, so t can never be 0 and it can never be negative. That means only a positive value of t is acceptable here. 24 is positive, so this value of t is allowed. So we can safely carry it back into the original setup. Remember that t was standing in for 3 to the power x, so the statement t equals 24 becomes something else. It becomes 3 to the power x equals 24. Now the unknown x sits up in the exponent. That is the part we still need to unwind. An exponent equation needs a different tool than a linear one. Before we do that, let us get a feel for the size of x. We can compare 24 with some powers of 3. 3 to the power 2 is 3 times 3, which is 9. 3 to the power 3 is 9 times 3, which is 27. 24 sits between 9 and 27. Powers of 3 grow steadily as the exponent grows. So the exponent we want sits between 2 and 3. That already tells us x is not a whole number. It also tells us x should land fairly close to 3. 24 is much nearer to 27 than to 9. So we expect a value a little below 3. To pin the value down exactly, we bring in logarithms. A logarithm is the tool that pulls an exponent down. A logarithm answers a question about exponents. It asks what power a base must be raised to. That is why it fits an equation like ours so well. We will use the natural logarithm for this step. The rule we need is the power rule for logarithms. The log of a number raised to a power has a simple form. That power can be moved out in front as a multiplier, so the log of 3 to the x becomes x times the log of 3. This works for any positive base and any real exponent. Now we apply the natural log to both sides of our equation. The equation was 3 to the x equals 24. Taking the log of equal quantities keeps them equal. On the left, we get the natural log of 3 to the x. On the right, we get the natural log of 24. Both sides were equal, so their logs are equal too. Now we use the power rule on that left-hand side. The exponent x comes down in front of the logarithm, so the left side becomes x times the natural log of 3. So x times the log of 3 equals the log of 24. Here, both logarithms are just fixed numbers. The natural log of 3 is a constant and it is not 0, so we may divide both sides by the natural log of 3. On the left, that constant cancels and leaves x alone. On the right, we get log 24 over log 3. So x equals the natural log of 24 divided by the natural log of 3. That is an exact expression for our answer. Every symbol inside it is a known quantity. This ratio has a familiar meaning in logarithm language. A log in one base can be rewritten in another base. That conversion is called the change of base formula. The log of 24 over the log of 3 is one such ratio. It is the logarithm of 24 in base 3. So x equals log base 3 of 24. That is the same number written in a tidier way. Both forms describe the very same number. We can also break 24 into simpler pieces. 24 is 8 times 3 as a product. Logarithms turn a product into a sum of two logs, so log base 3 of 24 splits into two parts. The first part is log base 3 of 8, the second part is log base 3 of 3. A log of the base itself is always equal to 1, so that second part is simply the number 1. Now we can look at log base 3 of 8. 8 is 2 times 2 times 2, which is 2 cubed. The power rule lets that exponent come out in front. So log base 3 of 8 is 3 times log base 3 of 2. Putting the two parts together gives a neat form. X equals 1 plus 3 times log base 3 of 2. That expression is exact, with nothing rounded away. Some prefer one form, some prefer the other. Now we can turn this into a decimal value. Let us go back to the natural log version first. These logarithm values come from a calculator. We keep 4 decimal places to stay reasonably accurate. The natural log of 24 is about 3.1781. The natural log of 3 is about 1.0986. We divide the first number by the second number. That division gives about 2.8928. So x is approximately 2.8928. We can test this against our other exact form as well. Log base 3 of 2 is about 0.6309. 3 times that value is about 1.8928. Adding 1 gives 2.8928 again. Both roots land on exactly the same decimal. We can also try the same ratio in base 10 logs. The base 10 log of 24 is about 1.3802. The base 10 log of 3 is about 0.4771. Dividing those two also gives 2.8928. The base of the logarithm does not change the answer. That is exactly what the change of base formula promises. Only the labels change, never the underlying value. Earlier we said x should sit between 2 and 3. Our decimal 2.89 does sit in that range. We also said it should land close to 3. 2.89 is indeed close to 3. We can also ask whether another value of x could work. Powers of 3 keep increasing as the exponent increases. The function never repeats a value it has already taken. So 3 to the x can equal 24 only once. On the reals, that is the only value of x we can have, so the solution set contains a single number. That number is log base 3 of 24. We can also write it as 1 plus 3 log base 3 of 2. As a decimal, it is about 2.8928. All three of these are just different faces of one value. Writing the exact form avoids any rounding error. Now we should put the answer back into the original equation. This is the strongest way to confirm a solution. The original equation had 3 identical terms on the left. Each term was 3 raised to the power x. With our value of x, 3 to the x is 24. That is exactly how we defined the value in the first place. So the first term on the left is 24, the second term on the left is also 24, and the third term on the left is 24 as well. Now we simply add those 3 numbers together. 24 plus 24 is 48. 48 plus 24 is 72. The left side comes out to exactly 72. And the right side of the equation was 72. Both sides agree, so our value of x is correct. We can also check the decimal version numerically. Raising 3 to the power 2.8928 gives about 24. Multiplying that by 3 returns about 72. The small gap there comes only from our rounding. The exact form hits 72 with no gap at all. So let us gather the whole path in one place. We began by naming the repeated expression t. 3 copies of t gave us 3t equals 72. Dividing by 3 gave t equal to 24. Since t was 3 to the x, that exponent equation appeared. Natural logs on both sides brought the exponent down. Dividing by the log of 3 left x on its own. Change of base turned the ratio into a base 3 log, and splitting 24 gave the 1 plus 3 log form. The final answer is log base 3 of 24. As a decimal, that is about 2.8928. Thank you very much for watching all the way through. If this walkthrough was useful, a like is appreciated. And subscribing helps for more problems like this one. And we will see everybody again in the next video.